Hello, welcome to the last part of Unit 2, aka Learning Goal 4 Remediation. So about angle proofs. So the level 1 proof and level 2, they're both the same, is asking us to complete those proofs with the reasons. So again, always start off with your given. So KM bisects JKL. So that is our first statement always. And then the reason is given. So we need to piece this together. So bisect, right, it means cut in half equally. So if you need some help, probably just label it. So cut in half equally. So again, when it cuts in half equally, you want to make sure that aka the KM, which is right here, is cutting this big angle of JKL. So that means that both this 1 and 2 are equal to each other, which is how we got measurement of angle 1 and angle 2. Now, because it says bisect, we are going to use the definition or def of angle bisector. Again, because we know that it is 2 equal halves. Now, the way that we learned that angle 1 and angle 2 is their relationship. So again, they have a relation of vertical angles. So again, because angle 1 is vertical to angle 2, that means that these two are equal to. So 1 and 3 are equal. And then that is the vertical angle theorem. And then last but not least, we have angle the proof in the measurement of angle 2 is equal to the measurement of angle 3 because of the substitution property of equality. Now for the level 3, these are asking to find both of them. Now this one is a very unique one because again, this one has two different givens that we are using at the same time. So again, the first given is given, but we're missing the second part, but we know it's given. And the second part is after the n. So we would want to say, hey, the measurement of angle 1 is equal to 135. Now, I like to just always label what that means. So this is 135. Now, we know that angle 1 plus angle 2 is 180 degrees because it forms a linear pair because they're right next to each other, forming that straight line, and they are known as supplementary. So aka this would be definition of supplementary angles. And again, we are using the first statement for that. So I always like to just say, hey, we're using the number 1 statement. Now, what we did here is we already knew what our angle 1 is, which is 135, so we substituted. And now to get angle 2 by itself, if we were doing some algebra in here, we would subtract 135 from both sides. And then when we put that in the calculator, we get 180 minus 135 being 45 degrees. So aka we use the subtraction prop and technically of equality for that. Or you just say subtraction property. I think I would be okay with that too. Now, that is for level 3. Now, level 4 becomes a little bit more harder. So we gave you a workbank to kind of help you out on the very bottom. So we're going to use that. So for the first one, we have this first given. AB is perpendicular to BD. So aka, and this one also put them both together. So we want to include this one as well. So our first statement is going to say, hey, AB is perpendicular to BD. And I will just put a little semicolon there to represent N. Angle EFG and angle CBD are complementary. I just always say comp just to save some space for my reason. And again, the reason for that, I'm just going to draw a line to separate that because I'm heading over to the reasons a little bit. That is given. So that is given. So what I would do is just mark this off. So again, I use that. So I mark that off and I use the given. So I don't get confusing and use them again by accident. So we are going to use the first part about AB is perpendicular to BD. So again, AB is talking about this line in the picture and BD is talking about this line. AKA what we need to know is that this forms a right angle. So AKA, if we look at this, we know that angle ABD is equal to a right angle. Now, we know that because, again, we are using the definition of perpendicular. So def of perpendicular. Or you could say, again, if two segments are perpendicular, then a right angle is formed. Or you could just say perpendicular lines. So again, I'm going to cross out the first statement and the statement that has the definition of right angles. So boom, 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 boom. Or definition of perpendicular. Now, we should know what a right angle is equal to. So we would say, hey, angle ABD is equal to 90 degrees. So the measurement of angle ABD, is 90 degrees. So we cross that out. And then we will look right here. The only one that is related to the second one is the right angle one. So this will be the depth of right angles. Because again, we need to state that it is 90 degrees rather than stating that it's 90 degrees right away. We have to say it's right angle first. So that's why we would do definition right angle. So again, we would take this away. Now we are done with the first proof, aka the first given. Now we are going to use the second given. The EFG and ZBD are complementary angles. So with that being said, we know what complementary angles mean. It should add up to 90 degrees. So we know that the measurement of angle EFG plus the measurement of angle ZBD is equal to 90 degrees as well. And again, right here, we just have this one right here. And then that is the definition of complementary. And we will cross out, boom. Now we have nothing really to go by. We have nothing that connects to EFG or CBD because again, we have nothing. We know what ABD is. So what I would do is look back at our diagram. We only have one picture that has multiple angles in it. So what we want to do is focus on the angle. So we know that whole angle ABD, so equals ABD. And then we would want to do a segment addition or angle addition postulate, my bad. So again, we are going to take the two angles that are forming that right angle, aka equal that orange angle, and add them together. So the first angle that we have is the measurement of angle ABC plus the measurement of angle CBD. Now you could have done DBC, doesn't matter, but in this case, if we look back, we do have that the ABC plus CBD is equal to the measurement of CBD. So boom, 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 boom. And we got that from the segment addition postulate. Or not a segment addition, that should have been angle addition postulate. Angle addition postulate. So again, we would cross that out. I know it says segment, but it meant to set angle. as soon as we do that, we would want to replace what we know, right? We know some really important things about this, right? We know that angle ABD is 90 degrees based off of our third statement. So I would say, hey, measurement of angle ABC plus the measurement of angle CBD is equal to 90 degrees. Now, that would be the substitution property. So again, I would cross this out and also cross out one of the substitutions. We have two of them. They'll mark it out in both. Now, we also know something else equal to 90, correct? We know that angle EFG plus the measurement of CBD is equal to 90 degrees as well. So we would say, hey, the measurement of ABC is equal to the plus the measurement of angle CBD is equal to the measurement of angle EFG plus the measurement of angle CBD. And again, I'm doing the same thing I did with the first given, just drawing that little line, so you know that I'm just running over a little bit with that. Now, we know that because of the second substitution. We did two substitutions at the same time, or we replaced the 90, what we also know 90 equals. So substitution. So we would eliminate the very bottom word bank for the statements, and then we will eliminate the last substitution. So we only have two things left. We have the proof. With the proof is always going to be at the very bottom, so we could actually just cheat a little bit right here, which is EFG is congruent to angle ABC. Now we're going to do some algebra right here. So again, if you notice, I made a little bit of a mistake, but it should be on the other side. So we're going to actually add another one. So actually I will fix that really fast. So sorry about that. So the measurement of EFG plus the measurement of CBD is equal to the measurement of angle ABC plus the measurement of CBD. So what we notice is that we need to do some algebra here. So think of these as variables. So our goal is to get EFG by itself. So to do that, we would have to subtract the measurement of CBD from both sides. Oh, hey, look at that. We have both of them on the same side. So these will cancel out, which would leave the measurement of angle EFG is equal to the measurement of angle ABC. So we got that one. And again, we got that one from subtracting it. So even though it's not a number, we are still subtracting quote unquote a number from both sides. So it'd be the subtraction property. So we will do the subtraction. And then, of course, our proof, you could always write that down at the very end. So we would cross the proof out. And then we only have one. And again, we'd never want to say it's equal because our goal is to make them congruent. And we can't just say they are congruent because they are congruent. We have to say we know they are congruent because of the definition of congruency or congruence. Hope that helps you and gives you some guidance on the independent practice.